Hello everyone, you're welcome to this next session of our series, Data Science Master Series. During the last session, we looked at Python for Data Analysis Part 1 and we critically examined NumPy, which is number Python. Today, we shall look at Python for Data Analysis Part 2 and specifically Pandas. Pandas should be seen as the Microsoft Excel for Python. That is that part of Python that allows you to play around with data, see if you are working on Microsoft Excel in form of tables, kind of. What is Pandas? Why do we need it? It's one very important libraries that you cannot do without. As a data analyst, as a data scientist, as an AI person, it is very key that we understand it. It's a library used for working with data sets. It has functions that you can use to analyze data. It has functions that you can use to clean data, functions that you can use to explore data and manipulate data. So it's a very important tool for data transformation. It's one of those libraries that helps us to analyze big data and make conclusions based on statistical theories. It's very important. Pandas can clean messy data sets and make them readable and relevant. It is very important to every one of us as data enthusiasts. What can Pandas do for us? It helps us to answer questions such as: is there a correlation between two columns? What's the average value of a column or a set of values? What's the minimum value? What's the maximum value? What's the trend within a particular data set? What's the minimum profit? What's the maximum profit? There are so many questions that we can use it to answer. Those are just few examples. That is simply what Pandas is. Tonight, through this session, we shall look at Pandas series. We shall examine data frames. Please, I need us to see data frames the way tables are, the way Excel sheets are. We call it more of data frame here because it's similar to tables. So we are going to look at a way of creating a series. How do we get a data frame out of a series? Then we load some data, we export some, we do some cleaning and pre-processing before transformation. We do some filtering, sorting and grouping. Then at some point we are going to work with dates. Then we do some merging of data. Merging of data. We have in a situation whereby we have more than one, two, three data sets, and we need to make sense out of the entire set. So we have to do some merging. In other languages, we call it joins. Especially SQL Server, we call it joins. At the end of the whole thing, we'll have some examples to play around with. Every session comes with 5 business examples, but this particular one has more than 5 business examples. We're going to look at them critically. Now, let's crack on. Pandas series. I'm going to bring down this. I have my desktop clean. This is our folder. Those of us that started with me at the beginning from the first video, you will recall that we started with this folder. So go into my folder. This is the folder and the content. I want to run my Python from this folder. I'll just click at the top here and type cmd. Yeah, it gives you this black screen. Just type Jupyter Notebook. Yes, so it has loaded it. You can see at the top here Jupyter. So this is a Jupyter Notebook. I'm going to start a new series. So I'm going to, this is Python for data analyst 2. So I'm going to do new notebook. At the top here, where we have untitled, I'm going to put the name there, Python for data analysis 2. Rename. So the name is here now. If you go to the folder, you will see it there. Look at it here. Okay. Now, let's have our header. So we're going to start. I'm going to start with. Let me first put the header. Pandas tutorial. Pandas session. So here's our markdown. Good. Now, the first thing we want to learn about is Pandas series. What are series? A Pandas series is just like your column. Just see it as the way you see a column. Just a single column is called a series. Now, when we're dealing with NumPy, we notice that NumPy work more along the horizontal. If you want it to present your data in a vertical format, you will have to tell the system, you have to write either an if else or while a control function, a control flow to get it the way you want it. But in this case, instead of going through that rigor, Pandas has come to solve the problem. In other words, Pandas is giving us a better way to do it. So, to use Pandas, you first need to import it, to install it. To install it, pip install Pandas. That's it. I have it installed, so I should expect that it will give us something like requirements already satisfied. So something is coming. As you can see, this is done now. That means it's processing the script. Requirement already satisfied because I had installed it. Now, we just mentioned that a Pandas series is just like the column of a table, and it is a one-dimensional array holding data of any type. Remember, we have discussed this. Now, to use Pandas, you need to import it into this sheet, into this book. Pandas, but I don't want to be calling the name. I need to give it an alias. PG. So I'm done with that. Good. Now, if I have a list, a list like x equals something of this nature, 2, 4, 6, 8, 10. This is a list. If you run this, it gives you the way it is. But I want to form a series. That means I want to form a column of a table out of this. So I'll turn it to something vertical. And how do I do that? Let's call it, which name do we call this now? You can call it any name, but what I want to do is I just want to say BD series. Note the series. The series is cap. Now put that x, this x, into a bracket, into this bracket here. So let me call this MV. That's the name of my variable. So if I call that variable now, can you see? So it has brought all this. Remember when we were treating list, we had 0, 1, 2, 3, 4 in terms of their positioning indexes. That is what you are seeing here. So see Python series more of, see it the way you see the columns of a table. Now you can use MV or use print MV. It's the same thing. Same thing. Now let's assume we have labels. We have labels. How do we treat that situation that has a label? How do we work around that? Something of this nature. I think I have a question here that I put down earlier on. Something of this nature. We want to create a series from a list of numbers. These numbers, and they have these labels. So that means we have A is 10, B is 20, C is 30, and the like. So how do we turn this to let me put this guy here, question. Okay, so what we want to do now is that we want a situation where we have two columns. One, we have something holding the labels and the other one holding the values. These are the values, these are the labels. So what do we do and how do we go about it? So that is what we want to do next. Now for us to be able to achieve this, we are going to do something that is we need to understand the ask, what those two stand for, what is a label, and what are the values. It is very important that we understand that part. If you don't understand that part, then that person is going to struggle. There will be a lot of struggle. So now, as we have just mentioned, ordinarily we can decide to use hand to say A equals 10, this is B equals 20. That is, this is 10 for A, B for 20, like that. But if we continue along that line, what we are trying to say is that if we have a very long list, is this how we are going to list them? No. So what I'm going to do now is this. I'm going to first create a list out of um out of what we have. Now with that list, we will now combine the list with the label. That's one way to do it. The other way to do it is that is to treat them separately, right? Which is not what I want to do here. Rather, I want a situation whereby we, we, we map the label to the series. So the first point, like I mentioned, is that you need to first understand the fact that the two are not the same. One is a label, the other one is not a label. So the label is like the index. The one that is not a label is something else. It's not the index. We call it the values. So what we can do, two things can happen here. We can turn this to a dictionary, and at the same time we can turn each of them to list and combine the list together. So those are the two possible ways of working around them. So what I'm going to do is this. I'm going to say X series, let me just call it X series, equals PD capital letter S series. I want to form a series, a Pandas series out of it. So I'll put this list inside here. That's one. I'll put a comma here, and I'll tell the system, you can indent it. You can say index, the labels are the indexes. Index equals the second list, which is this one here. So as it is now, I'm as good as done. If I run this, you can see there are no errors there. Let me call this now. That is it. So when you have a label, it takes away the natural index that comes with it. So basically, that is how that runs. Now the next thing that we may want to do is to create a data frame out of maybe something bigger than that. Is the same way. Is the same way. All that are required are just understanding of what to do. The principles remains the same. Understand the indexes. The index. Then understand the values. So if I have three things, what happens? I can have names. I can have something of this nature. I have a question here. Let me just put it up. Yes, this question here. I have this question. In this case, we had two lists. Here we have three. How do we deal with it? Right, so we have three. One of them is, we are told that the keys are column names. And these are the column names. and the values are the list of data. So these two are the values, city and ages. Okay, so what I'm going to do is this. To solve this problem, I will just copy this. It's the same way. Let me let me call this Ade equals PD series. Okay, so my key is this. That's the index. So all I need to do is to copy this because we are made to understand that these are the keys. Keys are the column names. So um, this one, those are the keys. Now these are data. Then I have another one. This one's city. Okay, so I become a there. Now I want to do, sorry, I want to do this guy. The list are, no, okay, I don't have this one. There is this one. I want to use this one first. That's the next question. I don't want. Okay, we have the names. We are told that the values are the data. Yeah, that's the age data. This is list of age data. So I have the list of age data here. I have this guy here. Yeah, this is the next question where we have three of them. So now if I run this and I call a dataset, it's so straightforward, and this is the principle behind the whole thing. We are going to make use of this from time to time, almost in every code that we shall be writing. We're going to include this kind of thing because it is very important that we get to understand what it means and how to apply it. The next thing I want us to do is that we are going to now look at a situation when we need to access a label. I want to access maybe David, no, Charlie. So all I will do is two things I can do. This whole data frame is Ade, so I can say Ade, then I'll just call maybe Charlie. But because it's not a number, I have to quote it. That's it, 22. Charlie is 22. That's the way of handling that. Now, what happens if we have something a bit different, like in a dictionary format? The approach remains the same. There is no difference. Same approach. So we've done that with two values, we've done that with one value. Then if you have that anywhere anyhow, you're likely going to have the same answer. Same thing. Now move on to from series to data frame. See data frame like a table where we have the rows and the columns, just like we have two-dimensional tables whereby we have two rows and two columns. That is a data frame. See your data frame the way you see a table. Now, for you to now form a data frame, this is a series. We can form a data frame out of this. Right, but before we do that, let us understand what a data frame means. In a series, one of this is an index which you keep here. The other ones will be the values. In a data frame, you have to specify index on your own if you must use it. However, the data values form the table. Now let's take an example. I'm going to take this example now. This same one. I'm going to use it as a data frame. So let me put a data frame, a small title there. Okay. Now, this time around, I have got three things. Let me first pick these two. From previous question, let's put numbers there. Question 1, question 2, this is 2, and this is 1. Okay. Now, what I want to do in question from question 1, from question 1, let us form a data frame. Form a data frame. Let's do that. Now, how do we do that? These are list of numbers and these are the labels. So we can say numbers label as title. Okay. Now what I'm going to do is, or we can use this. Let's do it. Just use 2 from question 2. 2 is more like it. We have the ages of people, then we have their names here. Instead of having them this way, we're going to have 1, 0, 1, 2, 3, 4, and this other one will form a table. So to form a data frame now, df, I'll call this df1, data frame 1. That is what we want to do. But before we do that, we need to put all this together. So what I'm going to do is I'm going to say data equals, as if I'm forming a dictionary. I'll now bring this inside. This is what? This is age. As if I'm forming a dictionary. I put a comma here. Let me take the other one up. Name. These are names. So I have my data. Now I want to turn the data from what it is to a data frame. So my data frame, this is my data. They're supposed to have a comma. Yeah, that's my data. Then my data frame df1 will now be pandas. I will now use pandas to turn it to a data frame. Data frame cap f cap d. I'm putting data inside the frame. So if I call df1 now, that's it. You can see the presentation now. Now, the case I wanted to resolve the other time, which I mentioned supposed to be question 3, is this. We have 3 things. This is question 3. We want to create a data frame using dictionary where the keys are these names and the values are this. Where the key are the names and the values are the list of data. These are the names up to here, and the other ones are the other ones. So are the data. So now first thing first, let's have our data equal to, open this. The first stuff there is name. These are the names here. Bring this in as a list. Okay, that's done. Then the ages, bring this guy in as a list. Then the city, so we formed excuse me, so we form our data. Now we need our data frame, so I'm going to call this df2 data frame df2 equals pandas data frame, then bring in your data inside the bracket, then call it, let's see, that's it. Now I want you to see the reason why I don't like the print function. If I put print here, I want you to watch the display. That's print. So this explains why I don't like it. Okay, now that is a way to work around data frames. Now I want to make use of some things, some small part of data frames that we are going to make use of as we get along. For example, we have this result with these tables. We have something called lock attribute that will return one or more specified rows. We need to be able to use such. lock. When you say lock, what does that mean? Now if I go to lock is from location, LOC, lock. Now if I do df, that's my data frame 2 dot locate, that's the meaning of lock. Locate, this is 1 2 3, locate 2 Charlie, locate 2, it will give us Charlie 22 Chicago. That's it. Name is Charlie, age is 22, city is Chicago. That's it. So if you now want a list of indexes, I want 1 and okay, let's do 1 3. Let me just do this. So give us if I do 1 and 3, it will give us 30 and 22. So 1 we did this before on lists. That's it. It doesn't say 1 and 3, 1 to 3. So you can do 1 to 2, depending on what you want. The only big difference here is that on that list, this is -1 to give you 2. That's a big difference. Okay. Here it will just give you the way you have supplied it, including the last number. Okay. Now, the next thing that we need to do is to say we want to locate by, let's even try to locate df2. Let's try something. Let's locate by saying Charlie. Let's even try something. I want to see what happened. Oh, sorry, I did not call lock. df2 dot lock. I want to see if it will take it directly like that. I thought as much. Charlie. Yeah, I thought as much. So it's just to check. Rather, you can do 2 if you are looking for Charlie. Okay. Now the next thing that we want to do is loading of files. Loading or import file loading or importing. Now to load files, here we need to be very careful because it depends on the type of files that you want to load. It depends on the type of file that you are loading. So that is where one needs to be seriously careful. Otherwise, it will it will go. You just discover that you are struggling with it. So how do we work around loading of files. The type of file that you want to load determines your code. Are you loading a CSV that contains data? Are you loading Excel that contains data? Are you loading a JSON file that is coming from API? Are you loading files from the internet? So depending on where you want to load it from. Now, if you are loading your files from CSV, it will be PD, it will be your data frame. Your data frame equals read underscore, PD dot read underscore CSV. Call the name of the file. If the file is in the same folder that you are using, like this folder here. So if I want this file now, dataset 1, I can pick it and say dataset 1, that's the name, and it's this CSV. This one is Excel. Okay, so I'm going to remove this. Now I'll call this my data frame 3. Now I want to bring in the CSV data set 1. Is there no data set 1? We have it. Data, let's check the folder. Is data set 1? Is there? df3 equals pd.read underscore CSV. Oh, okay, yeah, we need to put the type of file there. Yeah, that's it. So if it is Excel, this will change to Excel. It will be underscore this, and we'll pick the Excel format of the file. XLSX. But I'm dealing with CSV here, so the same way. Now if I want to see what is there, now I've loaded this, I can check the first 5 records to see what is there. Because if you do this, it will print everything, but I don't want to print everything. If I enter the way it is, it will print everything. I don't want it to print everything. I just want some part of it. So I'll do .head. .head will give you only the first 5 records from index 0 to 4. Let's try. Oh, it's df3, sorry. That is it. That's .head. Now if I want to see the last 5 records, I will do df3.tail. Don't forget, you can do more than 5. If you put 10 here, it gives you 10. If you don't put anything, it gives you 5. When I put 10 there, I'm having between 0 and 9. And if I put 10 here also, so the last record has a number, a serial number of 287. So our file is in. Now the next thing we may want to do is to find out how many records do we have, how many records and how many columns. So df3.shape. In this case, we have 2088 records and 140 columns. That's so many columns. So basically, that is a way to deal with your import. Now to export this out is same way. I want my df3 to be exported, df3 dot to underscore CSV. If I want to export it as CSV, I'll open the bracket. If it is in the same, I want to keep it in the same folder, then I will just give it a name, dimage dot CSV or lagoon dot CSV. Now if I run this now, it will drop lagoon inside the home folder. Let's go check it. I have it open here. See lagoon here. It has exported the records. So this is a way of exporting your data set. If you want to export in Excel, just put it here, XLSX, finish. Okay, so if you have a reason to pick your file from somewhere else, just indicate where it's coming from. For example, if I need to pick my file from, not from here, from my desktop, I think I have a folder on the desktop, from this other folder, from this folder here. Yes, I want to export here, for example, so I'll just come here and open it, carry this link and go back to my code, tell the system export, I'll put it here, then change this to /. Okay, so I'm saying that this should be exported to this folder. The same way, if you want to import from a different folder, you are just going to drop the whole location link here. So if I run this now, the file is in the new folder. Let's go check it. This is a new folder. Can you see the file here? The file has come here because we exported it here. So you can import from anywhere, you can export to anywhere. Okay, so we've done justice to that. Now the next thing I want to do is that is to look at some minor analysis. We've checked our data set, how many fields, how many records, how many this, how many columns, how many rows. That's the first thing. Then the next thing we may want to do is to see in our data frame. Let's check for more information. So use info. So what this is saying is that we have 2088 entries, 140 columns, then data types, we have float, 18 of them, we have integers, we have 9 of them, then we have objects are categorical variables, 113. That is what this means. So we've done justice to that. Another way of checking this is to do df3 dot dtypes. It gives you the field and the data types. You now see this 113 object. This is 1, 2, like that. The integer 18. This is one integer. This is another one. This dot 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 means you have a lot of columns. Remember, we have 140 columns. So those are the stuff here. Now you can check for null values. I'm just checking. I'm just checking what we have there. Whether we have empty cells there that we can delete, or those that we can move to somewhere else. So that takes me to the next part, which is data cleaning. How do we conduct data cleaning? What do we mean by data cleaning? The first thing that comes to mind in data cleaning is missing values. So to check for missing values, I will do my df3. I'm still using the same data frame that we uploaded. df3 dot is null sum. This tells me all that I want. So what is it saying is that this one has two missing values, this has two, this has two, this has two, like that. Then we have a lot of columns in between here and here. So this gives you an idea of those ones that are not there at all. Okay, so what I want to do now is that I want to reduce the data set to something manageable that we can deal with, so that we have proper understanding. So I'm going to reduce the data set now. Oh, okay, this is it here. So I'm going to reduce, I'll just take out some, because it's too large. So what I'm going to do is take out some redundant stuff inside it. Let me leave that one. This is Tanzania. So we have all these. I want to delete all these true false thing, so that we have something sizable that we can deal with. Okay, so we have is a good data set for it's a data set for animals. It's based on a research that was conducted. So okay, let's have all these ones out. Okay, so let me take out the rest. They have no value to me. So okay, so now we have something a bit better, more manageable. that we can deal with. So let me take out this guy also. So we have ABC to V. Okay, so this should give us an idea of what we can work with. Okay, so I'm going to save this. Yeah, I just replaced it from where we had it. Okay, so that's fine. Now I'm going back to my code, so as to change. I'll just rerun this. I hope that was the one I changed. No, I think it's the Excel one that I changed. XLLX. Yeah, this should be read_Excel. I'm doing all this intentionally so that you will have understanding. When you have issues, you know how to work around it. Okay, so I'm not sure this was the one. Was it the one that I checked now? It's running, so I'm just waiting for it to be concluded. Okay, so let's see. No, this is too many. Was this the one that I corrected? Let's check. I reduce the size of one now. Dataset 1, dataset 1. I think it must be the Excel one. Let's check. It wasn't this one. Let's check this one. Where's the one that I changed now? It's not here. Okay, so that's fine. So what I'm going to do is I'm going to change this one. Okay, so now I'm going to walk around this one. This is Tanzania. Then this one is, so you can take out this one. We can take out this one. All these ones, all this. Yeah, so I'm going to perform some small operations with it. So I'd like to use, that's why I like to use this file. It has everything that we need to do. It's a survey. It's the result of a survey. So it's a good stuff to use. So this one, this one here, all this one should go. Okay, so we have something sizable now. Um, yeah, I think we have something sizable now, which is still a bit better. Here to we can take down some more columns. We can take down this one. We can take down this one. Sorry, these two should go. Then animal ID should go. Should animal ID go? Let's leave it. Let's take out this guy. Then what again? This guy should go. Okay, so we have something sizable now. So this is the Excel sheet. So let's now go back to our code. Yeah, let's run this thing. This one. Let's do 5. Okay, so we have, yeah, we have all this. Okay, till, let's do till 5 also. Okay, then what's the shape now? 22 columns, the same number of rows. Okay, that's cool. So info. Okay, so now we'll see this clearly. These are the columns. So all these ones that are floats, they are numbers, decimal numbers. These are categorical, all the objects. Then the int, they are the integers. So if I come here to run this one, it gives me in a better way. Now I want to check for the missing values. Um, Now if you look at this, what this is saying is that we have on this column called country no missing value. On the column called data call ID, two missing values. Region has two missing values. Cattle roll has 15 missing values in that order. Now we may need to treat all these missing values one after the other, or we treat them all together. So like this one now that has a lot, the total number is 2088 and this number is missing. So what we need to do with this one is to drop it, because it's not giving us what we want. I mean, it's too much of missing information. All these other ones are not significant in terms of their number compared to 2018 records. Okay, so there are two ways to correct all this, to clean this record, I mean this data set. One way is to do it one by one. The other way is to do it such that you take, because all these ones that are objects, they are categorical. They are categorical. They are categorical. So you first identify what you want to drop. You take it down. So here we don't want data column ID. We don't want unnamed. Don't want these two. We don't want country because we know it's Tanzania. Everything there is only Tanzania. It's just one record. So we don't want that. Then um, we need to take down bull higher. Bull higher, this one. So those four need to go. Those four need to go. So the question is, how do we drop them? How do we drop them? So now for us to drop them, what we are going to do is that we are going to tell the system to get those two and drop them. Just get them and drop them. Now to do that is simple, so that we don't waste our time carrying them along with all that we want to do. Now my data frame is df3. I will say columns to drop is equal to, I'll just put this, and I'll just put all of them inside it. This is one of them. I'll do this. This is another one. They are not relevant to our course. I purposely left them so that I can show you this. Then country, it has only one value because the data is from Tanzania, so we know country already. Okay, so we have that. They want to remove bull higher. Please note that this will not leave your original data, but it will be away from the data set. That is the beauty of data frames. So I've kept that one there. Now to now drop, we'll now use this code. Our data frame is data frame 3, so I will say data frame 3 equals data frame 3, the same data frame. I don't want to change the name. Dot drop. What are we dropping? Columns. Columns equals columns to drop. This one. Finish. So if I call my df3 now, I've taken those ones out. If I run this code now, let me copy and paste it here. They are out. Now the next thing we want to do is that anything that is categorical in nature, they are the ones that we call objects. The standard practice is to replace them with the mode, their mode. Replace them with their mode. Now, when you are doing that, you need to be very careful, because we can replace wrongly. For those ones that are not categorical. You can replace with their main or you replace with their median depending on your choice. Now what I'm going to do in this case is that I'm going to replace I'm going to do it one after the other first. Let me see. We have float here, cat 2 years. I'm going to replace cat 2 years with main. That means anywhere there is blank space, I'll replace it with main. Cat 2 years. So to do that, this is cat 2 years here. This 15 will go now. As soon as we are done with this, we want to replace it with the main. Now, um, what we're going to do is this. I will say that we will fill it with it. We'll say that um, let me call it cat 2 years main equal to, I want to calculate the mean, df3 cat 2 years. So calculate the mean. Okay, now the mean is calculated somewhere. So if I let me run this for you to see it. That's the mean. Cat 2 years is 38, about 38.04 years. Now I'm not using this one here. I want to replace it now. My df3, the same df3. I want to replace it with the main, the blank stuff there. So I want to replace this dot fill now. That means fill NA with what? With the cattle mean. When you have filled it, replace it. So that is in place equals true. Done. So if we run this now, we should not have, we are going to get this to be 0. There will be no missing value there again. Can you see now? Cat 2 years is now 0. We've removed the missing value. So we're going to do the same thing for which other one again has float, animal age. So I'll just copy all this and paste here. This is animal age mean. Animal age mean. Done. So copy this. You can see that the moment you do one, you can, the rest is just copy and paste. Animal age. This is, so we are done. Now if I run this code again, animal age should be 0 now. There should be no missing values. Can you see now? Animal age is 0 now. This is a way to clear it. Now the other ones are objects and there are many. If we start to do this one by one, we'll do it how many times? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 times. That is going to waste our time. uh, that is going to um, waste our time. So we're going to use one code to do it. Um, Now to do that, we'll put all this together as one with using one variable. Good enough. We've done for statement, so we're going to use for statement. Now all these other ones here, they are what? They are objects. So you can see they are of the type object. So what I'm going to do is this. I'm now going to say for any x in the data frame 3 dot select d types, that means the data type, d types include equals object. That means you should go and pick all the objects and bundle them together as one, or dot columns. Sorry, dot columns. For that means for every x inside all this data objects, what do we want the system to do? Find the mode value equals df3 column. Remember df3 column dot main. That one will be dot mode, then 0 here. Okay, so dot mode is 0 here. Now when you've calculated the mode, then for every one of them, go to column, fill any one, fill now. That means any blank space, fill any blank space. Now is blank space with what? Mode value. In place equals true. df what do we do means, oh okay, this is x, not column. For every x inside here, yeah, yes, this is df3 x, yes, that's it. So if we run this code now, there will be no missing values again. As you can see, everything is clean now, no missing values, no missing values. Now we've dealt with missing values explicitly. Now let's deal with duplicates. So we need to check if we have duplicates in the record set. To do that, I'll do duplicates equals my df3, then df3 again dot duplicated. There's a function called duplicated. So if I call this now, it should give us those records that are duplicates. So in this case, we do not have any duplicates, so we are good. We are good. So no duplicates. Now the next thing we need to do under data cleaning, which is the third thing, we've considered missing values. So let me put something here. Duplicates. Let me put a header here also. Data cleaning, then missing values. Missing values. Okay. Then 2, this is 2 duplicates. Correct. Now the next thing we want to do is that we want a situation whereby we are able to check whereby we're able to check for wrong format, or we're able to check for wrong format just to be sure we have everything in the proper format. Now to do that, we need to bring in a function here. So the function will check for string, will check for float, will check for object, will check for integer. But in our case, these data sets, in this data set, we do not have integer. We've dropped our integer, we've dropped our string, so I think we are good there. So the next thing we're going to do is, let us assume we don't know, not until we check the formatting. It is possible for a wrong value to be there. It's not empty and it's not duplicate. So wrong format, wrong data format. I want to check for that. Run data formats. Now to do that, as mentioned, we are going to get a function to do it. We have to write the function. Remember, we have treated function before, but now I want to make use of it. I want to define my function here. I want to call it check wrong format. Check wrong format. And this will be dependent on df. So now the first chain is our df3. So what are we going to be checking? So wrong formats. Let's create an empty data frame to accommodate the wrong formats. Empty data frame. Empty dictionary. So we've created an empty dictionary. One has a 4 column in that data frame, df3 dot columns. That means for every column there. If that column is object, the system to check that there are no numbers there. If df3 column dot d type is object, what do we want the system to do? We want the system to try df as column, df3 as column, df3 column as type float. That means look for this, then value error. That means if you see wrong value error, except value error wrong formats column, wrong format column equals my df3 column. Then we'll now place another square bracket here and use this sign, df3 again column dot string dot is numeric. That means he's checking now is numeric else. So my else is under the F, else wrong format, this wrong format here, wrong format. Let me just copy this whole thing. Else wrong format equals that. So this should now be pd dot to numeric. So we now have our data frame 3 column. So if any error occurs, just coerce it. That means force the error. Okay, so coerce the error. column dot not any. Okay, so wrong format, return wrong format. So that's a function. I left out something somewhere. Will it be this one? Okay. So now the next thing is to run to check it for our data sets, our data frame. So I'll now say wrong format equals, I call the function and I feed it with my data sets. Oh, okay, I made a mistake, G here instead of T. Wrong. So this is wrong. Okay. SPF wrong format. Oh, okay. This is my DF3. DF, where's DF? Data frame to numeric. To numeric, okay, here. Um, okay, so now what we have, now what we have here is nothing but a code. This one here, the essence of having this is that when you put it in your data set, it generates the wrong formats, the records with the wrong formats, and when those ones are generated, it gives you an opportunity to resolve the issues without stress. So we have wrong format, check wrong format, depending on, that is dependent um, on DF, so DF3. if so for okay, we have this here. Let's even comment this guy out. We may not need it. Let's see. Well, it's just that if we have it, we use it to capture the wrong format. So for column in df3 dot columns, if df3 column dot d type equals object, that means if it's a string, then to check again for float, try to find df3 column as type float. Okay, except value error where wrong format on column. um, okay, before string here we can do, okay, after string we can do replace dot replace dot replace, then we'll open, we call the replace function, then here is another string. Yes, dot is, yeah, so what about replacing here? We are looking, it depends on what we are looking for. We are looking for, we are looking for dot, we are looking for dot, then we are looking for hyphen. Dot is one of them, so we need to quote it. Can looking for this, we should look for hyphen. We should look for hyphen. Yeah, I think it should work now. Oh, let's look for space. Then let's have a one here. So else wrong format column equals our data frame column. We can, where we have else, we can bring in our data frame here. You can df3 column, then we can bring in pd to numeric here. instead. So what we can do here is to say PD, since we want to coerce it, PD to numeric, then we now open this. Okay, that's this one here. Okay, error coerce, yes. Okay, it's now and df3 column not now. Okay, key value, there's a key value error, key error. We have this error here. So if you look at that figure very well, you will notice that that is the average that was calculated, so that we found there. So what that means is that there is okay, let's do this. So where we have wrong format here, we can take care of that value, that response, by okay, let's call this invalid entry. Let's say invalid entries. Invalid entries. Let's call this invalid entries. Okay. So what that means is that by replacing that, we'll now come down here to say if not, oh sorry, invalid entry. I want to pick invalid entry. Invalid entries dot empty wrong format equals invalid entry. Okay, so now we have the function working now. Okay, so what else have we not talked about today? We've removed duplicates. We've checked duplicates, no duplicates there. We've checked for wrong format. We can check for wrong data. Is it wrong format now or wrong data? Is it possible to have wrong data? Yeah, we can always remove those rows. Wrong data is actually subjective in the sense that it depends on for example, if you have a value, if for example you have a situation whereby excuse me, you have a value that should be between 45 and should be 45 instead of 450, then we need to adjust such. But we need something to tell us that it's supposed to be 45 in that row. And how do you want to know that? Now, what you can do is, that is why you need to check through your data. You need to look at your data very well and find when you will notice, you will see what is out of place. If everything is two decimal is two digits, for example, in time maybe duration 2 digits, and a particular one is for saying 1000 4 digits, then it's out of place. It's out of place. So these are things this we need to check, and when you see it, it's just to use the replace function to check it. That is anything greater than anything that looks abnormal. So that is why you need to check your data from the onset. So we are done with this part of pandas that we need to do. Now the other thing here, if you look at our plan, where is the plan? We've done all this. We've done all this. Now we need to look at this and this and this, which is the next one. So data transformation. What does it mean to transform data? We are still going to look at examples. What do we mean by transforming data? What do we mean? What are we transforming? What are we doing with it? So what that means is that we need to write the code for some filtering, some sorting, some grouping, um, some grouping depending on what is required. So it depends on the question or the ask. There are so many things that can be done. If you look at the data set, you can do scaling to find out what's out of place. You can do log transformation. You can do so many things with it. But I don't want to go far into all those ones. Rather, I want to sit around the simple transformation so that we are able to see what works. Now I'm going to going to transformation now. I've done the part of it really. For example, you need a particular column just to specify your df3. Let's pick education for example. I want to see only education. df3 education. Oh, sorry, df3. That's it. So that means we have some repetition. So let's see the unique elements there. Value, value counts. That's it. So that means under education we have primary 1494, we have tertiary 303, we have secondary 241, we have none 38. Then we have another. Now look at this. This is wrong format that we're talking about. This is supposed to be tertiary. It's supposed to be this. So we need to write a script. We need to write a script that will do that. a script that will replace um, uh, to replace is it tar yeah, okay, that starts with tertiary. So that is what we need to do. Now, how do we go about doing that? We need to use the replace function. That whenever the system says that yard should replace it with tertiary. Okay. Now, watch how that will be done. df3 education. That's this one here. I'm putting it here, and I'm saying that this data frame is the same thing as that, but replace. What are we replacing? What you are replacing is on your left. I want to replace this. Can you see that if you don't do this now, you will not see the wrong values? This is the kind of wrong values that may not be apparent, in the sense that is in the data is a string, so it's correct, but the value is correct wrong. Is a string, the column value is also a string, but the value inside is wrong. So I want to replace this with, so put a comma here, with what? With this one. Run. Done. So if I do this again, that should be fine. Can you see now? Now we have tertiary 315, secondary none. We are done with this. So you can write whatever you want to do with this guy. This is grouping. We are transforming the data for the purpose of insight. In the next session, we're going to look at how to turn this to a chart. But that is not the subject of this video. Now we keep transforming. Let's go. Gender. We can find out what's going on gender. So it's to do the same thing. Then region also. Let's do the same thing. Gender value count. This is correct. It's fine. Then what again? Region. That's it. Here you can say, look at this region. This is Tanga, T, K, A. You can arrange them in alphabetical order. It's just to do sorts. Put this guy. Yeah, we can make it yeah, it's because of the way we've called it, but we can always find a way around it. So what we need to do is to make this a, what do you call it, a variable. They will now call the sort function. That works. Right, so I'm going to do that, but before that I want to believe so far we have done justice to this guy, to the whole stuff. Now if summarize this, we can say that we want to sort in ascending order, in descending order. It's up to you. Now let me sort this region. Let me call it df3 sorted. df3 region sorted equals what are we sorting? We want to sort by region. df3, that's our data frame, dot sort underscore values. That's one way of sorting. By we're now doing equal to by what? What do you want to sort with? Region. And when you have done that, you need to tell the system whether you want ascending or descending. Ascending equals true. So we've sorted df3, but let's do something here. Let's reduce. Let me call this df4. df4 equals this. Right. So what that means is that if I call my df4, it will give me those things. Cool. So I can now come here and say, okay, my df4 we just sorted. So this will be df4, so that you arrange only this one. Sort value, region, yeah. What did we miss? Come in, let me do this guy this way. Any arrangement? The arrangement is still wrong. Okay, yeah, this sorting is by values, but I don't want to sort by value. I sorted this by value, as you can see. So if you want to sort it in descending order of values, all you need to do is to turn this to false. Then this will be in front and ahead. So it has changed now. So that is sorting by value. Because it's saying this as index. Fine, you can sort by this one also, but yeah, you can sort by that. I want to try something. df4 just occurred to me to try it. I just want to give it a shot. Oh, okay, yeah. So so it's within my expectation. Cool. So this is how you are expected to sort your values. I want to sort by this, I want to sort by that, and so on and so forth. Now, sorting by this one is something that is coming up in the next stuff that I'm going to do. So I'm going to explain to us how to do all those kind of stuff. So I want to believe we've done good justice to this whole thing, end to end. Please do not forget to drop your notes. If you have any question or something contribution, please feel free to drop it in the notes. We can do a lot more aggregation, a lot more analysis depending on what we want. We can do by reason, the same analysis by reason. You can do by live training and the rest. Okay, cool. So we're done with this. Basically, just some few things that we want to do. Now, the next thing I want to do is to consider some possible exercise questions. I think I have a couple of questions I put down somewhere. I hope I can get them. Okay, yes, I've seen them here. Um, okay, where we have a data set, some raw and missing values. You want to fill them with the median age, so that one is clear to that one is not a problem to anybody. By now you should be able to, I believe everybody will be able to do that one. It's straightforward. There is no what do you call it there is nothing tricky there. It's straightforward, as straightforward as you must have seen it. Okay, so the next thing I want to do is to talk about those questions. Just looking for where I kept them. I think I kept them somewhere here. Transformation. Okay, yes, I've seen one of them. Right, so this is one question. Let me just grab it. Um, so this is it. Okay, you have a data set of sales records that includes product category, sales, and dates. They are all provided for us. So let me just drop them. Um, I want to grab the data sets. Okay, so we have products, we have, I think, then the other one here is category. Then we have, it's actually a data frame. I mean, sorry, something like something like something like a series, but not really a series. But yeah, it's like a data frame, but a set of series, kind of. So we have, let me punch them here. So we are given those ones. Um, Product. Then we have category as product category now. Then we have sales values. We have dates. Correct. Yes, this is what we have. So the question now is, how will you filter the data set to show the records that were, so where the sales amount is greater than 1000? This is just all that we have. Now, to solve this problem is simple. Just dump them as a data frame. Create your data. Just have data equals just exactly the way we have done it. Our data frame, you dump it like a dictionary, but multiple this is sales, but multiple what do you call it, multiple multiple lists. So I have this, that's the where's the product, there's the product here. So I'll call this product. Make it a list, put a comma here, then category, this is category, uh, make it a list. The next one is sales. This is sales. Then the next one is date. That means the dates on which the transactions happened. Dates. Okay, so we have our data now. Now the next thing we want to do now is we'll turn it to a data frame. df equals pd dot, remember our formula, cap f data. So that turns it to a data frame. Let's check data frame. That's it. So now we want to filter. So filtered data frame equals me looking at this, we know the answers. Sales greater than 1000 is 1, 2, 3, but we want to write a code just in case we have something that is longer than this. So how do we write a code to filter such? So we'll do df, inside it pick another df again. Now pick this, the what do you call it, the column sales, where sales is greater than 1000. That's it. So we're done. Click on this guy to give you that data frame. That's it. That is it. Now I mentioned earlier that I'm going to explain sorting in the next question, so this is what I want to do next. So I want to explain sorting properly, the way it works. Now the question is, how would you sort the sales record in descending order? based on the sales column. Let me mark down so how are you going to sort it? It's simple. Sorted df equals df dot, remember this is our df. We want to sort the above sales records in descending order based on sales column, this one, descending order of this one. So equals sort underscore values by what? By equal to sales. Put a comma there. Ascending equals true. So let's call sorted. Can you see that? It's in ascending order now. Now, if you want it in descending order, simple, it's just to change this guy to false. But this must be ascending at all times. Change this guy to false. That's it, it has changed. Okay. Now let's try to group some records. You can see that some are electronics, some are furniture. How much was made by furniture? So how are we going to calculate the sales record? By category, and calculate the total for each category. So you want to say electronics, this is the amount, furniture, this is the amount. That is grouping. So we are going to group them by category. Now this teaches you how to group data. So that will be grouped df equals our data frame dot group by. Just call the group by, and inside open a bracket, keep the category column which is of interest to us into it as an argument. Now we are doing that against sales because we want to sum sales by that category. You are grouping by category, but you are summing sales, so that's why I'm bringing sales into it now. Sales dot sum. Sales dot sum. Then reset underscore index. Now this means when you pick electronics, you are done summing it, go back and pick the next one. Underscore index. Done. So let's see. We have two categories, so we should expect two entries, two rows. That's it. So the total for electronics is this. Let's see. 0, 5, that's 50. 1 remainder 1, 4150. This is correct. Yeah. And this is 5, 16. Yeah, this is correct. That's it. So that's a way of grouping. Now, another way to look at it is to have to group and to filter at the same time. So how will you filter the sales record? To include only those sales greater than 1000, and then group the filtered data by category. We want this, but we want it for only those ones greater than 1000. That's the meaning. So let's see. Um, this is so how are we going to do that? So we want this table, but for those ones greater than 1000. So we want to filter, we want to group. So filtered, grouped. Let's form a name, df data frame equals df our data frame again, then the sales, remember we had this greater than 1000. That's the first code, this one here. We have the result group by, bring the group by formula same way. Let me just copy it straight away. Group by category and the rest. Then pick this and drop it here. Yeah, that is it. Remember, these ones are not greater than 1000. We want only the sum for those ones greater than 1000. So that's it. Okay. Maybe the last thing I want to do is to sort grouped data. This one that we grouped here, we want to sort it. So we want to do that together. How do we sort in case we have something massive to deal with? So just like the case of this case here, the case of education region, so we may want to find all those things, all those grouping, but these are not, those ones are not money, so we can sum them together. Okay, so now we have this. Okay, so now what we want to do is let's form a variable name, grouped sorted data frame equals, is straightforward. First group it, dot group by. Where is group by? Okay, this is group by here. So you first pick the group by thing completely the way it is. Then outside here, just put it there. Sort underscore values. By what do you want to group? By what? By sales. So that's it. can do ascending equals false. Remember, we are sorting by sales figure. But we want it in ascending, so it goes through. Good. So this brings us to the end of the plan. The only thing that remains now is merging, which we can merging, joining, and concatenating DataFrames. So this guy will be we want to see what happens if there is need to join or concatenate data frames. How best can this happen? What should be the approach if we have more than one data frames to deal with? How do you want to put them together? So what I'm going to do here is that I'm going to use example to answer the question so that it makes sense to us all. Now the first thing is this. Let us assume I have two data sets. One is the employee data set, the other one is department. I have the questions already. Let me put it here. Question. Okay, so we have this. You have two data frames, employee and departments. The employees are, we have three of them. We are given their data sets as 3. Then we are given the department as 2. So the question is, how can we put them together to make sense out of it, out of the whole thing? So we have employee ID 1 to 3. Then we have department ID 100 to 103. Then we have employee names also. So these are the things provided us with. Let me see the departments data frame. Okay, departments and the department column this that. How can we? So these are the employees, employee IDs, employee names, then we have the department ID. Yeah, this is all that we have. How can you merge these two data frames to get data frame with employee names and their respective departments? That is the ask. Now it's simple. Again, as usual, form your data. Form your data from what you have been provided with. Employee ID. Where is employee ID? These are employee IDs. Employee ID. Employee ID. Yeah. So just put them as list straight away. The system is, I mean, the Python is so intelligent that it will grab them. Then employee names. Name. Then department. Department. Okay. Now we have that as provided. But when I have something separate also for the department. Oh, okay. The departments are um, one HR and 102 engineering. Those are the departments. Okay, so we need to form another data. This is employee emp data, and this is department data. Same way, we form a list, department ID 101 102. Then department's name, HR, engineering. Oh, okay. Yeah, okay, because we have two of them, so I'm going to put this in a bracket and close this guy, then put this in a bracket and close that guy. Employee ID is not defined. Oh, so okay, we can do it this way. Let me do it directly. I don't want to do that before. Employees equals PD. I'm converting to data frame straight. Okay. Okay. So then departments also are converted to data frame directly. This will be PD data frame. Yeah, so employee ID is not defined. Oh, it's because I did not quote it. Can do it this way, can do it individually the way we did it before, the way we did the other ones, so that you not do separately, you point them to a data frame. So we had the two data frames now, employees, then we have departments. Good. So what we want is, we don't want this guy to be using this number. We want department name here. Something like that. Even if it's not there, we just want these two. We want to merge this on this because this is a common field to the two of them. So merge underscore df equals, we want employee the way it is, so employees employees, so pandas first, pd dot merge, that you merge an employee on the left, comma, departments on the right. On equal to, that's the common field now, department ID. So the merged data, that's it. So you can now take down this guy. by using drop columns. That is using df whatever it is. We did that before, so don't want to go into all those ones again. So that solves that problem. So in that case, you have joined them. Now in another case, you may want to join to keep one side, to keep the table on the left everything, or keep the table on the right, whichever way. All those ones are dependent on the ask. Now if you want to bring the two together technically, then you have to make them to be two different data frames, which we have done already anyway. We've done that already, but all you need to do now is to use concatenate. But when you are concatenating, for you to use concatenate, this what you have here, the column here must be the same thing as the column here. I mean the column types. You can't concatenate these two because they are not the same. Can't use concatenation here. So if you want to concatenate, you have this table, you have another table of this nature, you want to merge them. That's concatenate. Okay, so I think we've covered a lot part of the whole thing. Yes, with enough examples. So I want to believe this should sort out somebody's issues. Whatever you want to find out is here. Just the code is here. All these codes can be reused. All you need to do is look at it, then sort it out directly from it. Please, if there is any question, let me know by dropping a comment on the YouTube channel. For the comments could be for improvement, could be another ask for new thing, could be your question, it could be request for additional videos that you want me to come up with that explains it. Hope you enjoy this. See you in our next version of the series. The next session will be on data visualization. That is when we'll start talking about all the charts. Please subscribe and do not hesitate to be part of it. Thank you. Bye.